In this video, I'm going to discuss the law of sines. This is the law of sines. It works for any triangle. And I remind you that, so if we have a triangle ABC, which I'm just arbitrarily picking which angle to call which, the names really don't matter. But once you've established the names, it's very important what the side names are. So if this is angle A, side A is on the opposite side. Angle B, side B is the opposite side. Angle C, side C is the opposite side. If you're going to use the law of sines, they have to give you 3 pieces of information. And those 3 pieces of information have to fit into 2 of these parts of the law of sines. So for example, if they told you A, and B, then you could ignore this part of the law of sines and you could solve for angle B. Or, alternately, maybe they can tell you 2 angles, one of the sides, in which case we would ignore the middle part here, and we could solve for side C. Okay, so in those 2 situations, that's when we use the law of sines. In one of those situations, if they tell us 2 angles and 1 side, this is completely unambiguous. There's only one triangle. There's only one triangle in that situation. Okay. However, and we saw this today, if they tell us 1 angle and 2 sides, and this angle is non-included in the sides. 1 angle that's not included in these 2 sides, then you could have. It's possible that there are no triangles that match that. You could have 1 triangle or you could have 2 triangles. This is because of the ambiguous case of the law of sines. What we're going to do is to actually look at when these situations arise. Okay, and so these are the notes from today. This is pretty much what you have to learn. We are assuming that we're given angle A and the sides A and B. Again, in this situation, these are 2 sides. This is one of the non-included angles. Okay, what I am going to do in this video is to demonstrate to you, using this GeoGebra file, what I'm going to have you write down for your notes. Now, if you're curious, you can open this GeoGebra file. You can download it. It's available on our website. Okay, past the links, past the homework. It's in the files section. It's the GeoGebra file.ggb, the ambiguous law of sines. Okay, so first, again, in the notes, first case is A is less than 90. So I'm just going to pick an angle less than 90. How about 53? Okay, and let's see. We're going to follow the cases here. Now, in the first case, let's consider if A is greater than or equal to B. Okay, so I've got B equal to 3. It's already set equal to 3. So let's look and see how many triangles we can create. As I swing it down, and again, it has to touch this dotted line so I maintain my 53-degree angle. I get to 1 triangle right here. And if I keep moving it, when it touches the line again, I've just got a straight line. That's not a triangle, but this is. And so if the angle is acute and A is longer than B, I have 1 triangle. Now I've got several situations where A is less than B. And we start at that point considering what B sine A is. In our example here, B is 3 and A is 53 degrees. So let's see what that is. Let's see. B sine A in our example is going to be equal to 3 sine 53. And I'm going to use a calculator to get an approximation for that. 3 sine 53. Okay, 2.4 about. So what I'm seeing here, I'm going to close the calculator. What I'm seeing is if A is equal to 2.4, or let's see, let's say A is less than 2.4. Let's make A less than 2.4. Okay, 2.5, how about 2? If A is 2, you'll notice that it just will not reach. It will not, I can't pull it down far enough. And so we have no triangles in this situation. Again, A was acute. it's less than B, and moreover, it's less than 2.4. It's less than B sine A. No triangles. Let's see if we can make it exactly equal to 2.4. Well, not quite exact. We can get it pretty close. If I make it 2.5, let's look and see. So this is going to be just a little bit too long, but imagine if it was just a little bit shorter, I'd be able to make one triangle. It's the one where it would hang straight down. And again, I couldn't make it 2.4, so it's a little bit long, but that would be the one triangle that I could make. If, however, it's less than B, which again, B is 3, we need it less than 3 and greater than 2.4, so I'm going to have to use 2.5. So what I can see is, let me get out my cursor, what I can see is that it really is long enough to make two triangles. I've got one triangle here, and I can also move it to the inside, and I've created a second triangle. So that would be the third case here. So when A is less than B, there's three situations. One, it's less than B sine B sine A, so it's too short, no triangles. Or it could be exactly equal to it, in which case I have one triangle, or maybe it's greater than that, in which case I have two. This is the ambiguous case. Okay, and then finally case 2, which is much simpler. I need to start with an obtuse angle. How about 153? Yeah, they're going to let us do 153. Okay, and you can see in this situation, if side A, which in this case is 2.5, if it's less than 3, it's just not going to reach to make a triangle. Even if it's exactly equal, it's not quite going to reach. It's actually just going to make a short line segment. So what I'm going to have to do is increase the length so that it's longer than the other one, and I can only make one triangle. So again, in case 2, either A is it's less than B, so there's no triangle, or it's greater than B, there's one triangle. That is all.